Waiting. Hello? Can you listen? Boleh dengarkah suara saya sekarang? Ya? Tak dapat lagi? Audio boleh dengarkah boleh dengar suara? Boleh dengar suara? Kalau boleh sila reply. Kalau boleh dengar suara? Okay. Can listen the voice. Okay, now that's good. Yeah. Okay. Okay. Now here's better. Okay, let's start our lesson. All right. Sorry for taking up your time. Now, let us just look at the screen. Yeah. Let us just look at the screen. Yeah. Okay. So you don't bother to write down the notes here, because later on I will just share whatever notes written. I will just share this to you through the WhatsApp. Yeah. I will print screen everything, and later on you can copy. Yeah. Right now, you just open your ears and listen. Try to understand the concept. Try to understand the steps. Yeah, how to solve the problems. All right, everyone. Can we start now? Can we start now? All right. Okay, that's good. Okay, so now okay, so we start with question 4. Okay, 4B. Yeah, let's 4B. Okay, a resistor, okay, given the resistance, capacitor, right? Capacitor, with this capacitance, inductor are connected in series across this AC source, 240 hertz, for which the Vmax is 140 volt. Calculate impedance of the circuit. Okay, first of all, we must understand that we must identify what kind of components included in this circuit. So we have okay, so we have a resistor here, we have a capacitor, we have an inductor. So it is an RCL circuit. Okay, RCL circuit. Okay, that's good. Yeah, thanks for your response. Yeah. Okay. We have is RCL circuit. This is very important. First, you must identify what kind of component. So this is RCL circuit. And then the source. This is the AC source with this frequency, and Vmax is 140. So this voltage is for the source. This voltage is for the source. This is the source voltage. Okay. And maximum means the peak voltage lah. Okay. Maybe it's just maybe I want to adjust the, yeah, I think that like that's better. Yeah, like just now it's too thick. Yeah, maybe I should adjust the thickness of it. Yeah, just hold on a second, please. Okay, now that's better. Okay, so we have here this is the source voltage. Okay, this is the source voltage. Vmax. Okay, so find the impedance. So if you want to find impedance, remember cannot just total up all the resistance. Yeah, we must draw a phasor diagram. Yeah, put them into phasor diagram. Okay, we have to learn how to draw the phasor diagram. Okay, so first of all, you must have the axis. Yeah, axis, x and y axis, and then the current at the x-axis, and the resistor is always in phase with the current. Okay, and then XC is below, XL above. That's always the traditional method. Okay, because we have 3 components, so you must have R, you must have XC, and XL. All right. But before that, we only have resistance, capacitance, and inductance. We don't have XC. Yeah, we don't have XC yet, and we don't have XL yet. So you need to find that first. Yeah. So find XC and XL first. Okay. Their formula XC is 1 over omega C. Okay. Or 1 over 2 pi FC. Then you just put in the values. Yeah. You have the frequency already, and you have the capacitance. Just plug in the value. And this is the value you got. Yeah. And then for the XL, also the same, omega L. All right, omega L. 2 pi FL. Okay, just substitute all the value inside, you get another XL. You see, all these are resistor. Yeah, the resistance itself is 900 ohm. You see that? So all these three opposition to current, they have the same unit, ohm. Okay. You got already R, XC, and XL. So you must draw the phasor diagram. Okay. Resistor in phase with current. Okay. And then for capacitor, XC is lagging behind, and then XL is leading. Yeah. Normally it's like that lah. Yeah. XC is below, XL above. R is with current. That's all. Okay. Now, if you see here, XC and XL, we compare first. We compare which one is bigger. XL is bigger, isn't it? XL is bigger. So you must draw the XL longer. Draw the XL longer, XC shorter, because XL is bigger. Okay. Then we use big minus small. Yeah. We use the big minus small. So got resultant upward. You see, got resultant upward. XL minus XC, we got the resultant upward. This is the resultant. Yeah, minus that first. And then we Pythagoras theorem between this XL minus XC with R. Then we get a Z. You just use the Pythagoras theorem. Okay. Yeah. This one, the X is the R, Y is the XL minus XC. So R square plus XL minus XC square root, then we get the impedance. That's it. Okay, this is the impedance. So we got the answer already. Yeah. Now, the next question, he asked for the maximum current delivered by the source. Okay, maximum current by the source. Okay, first of all, here you see, here this is the frequency, 240 hertz, and then this Vmax. This one voltage refer to the source, because this voltage is written just beside the source, isn't it? So this is the V source, yeah, and it is I write it as like this, yeah. I write it over here. This is a V naught source, maximum. Sorry, because it is maximum. Okay, maximum. So it's V naught. V naught. And this source, it refers to the source. So V naught source equal to 140 volt. So we already have the V naught source. Now we want to find the, let's say this maximum current is considered the I naught. The I naught. So very easy. Just use the V naught source equal to I naught Z. We already have the Z, isn't it? So just V naught source, because source refer to the Z. Source is for the Z. Okay, source is for the Z, for the whole impedance. Okay, so just put in the values there, and then you are on your way to get your answer. Okay, so this is 140, and then the current, you want to find the current impedance is 1434.72, and what's your I naught? Your I naught is I have calculator, but I don't have the time to calculate for you. Yeah, so you later on you calculate yourself. So I naught is this lah. This is the answer, 0.0976. That's the answer. Okay, very easily done. Now, okay. So later on, what else? We want to find the phase angle between the current and voltage. We want to find the phase angle between the current and voltage. That means you want the current I, and this is the voltage. This voltage is a V source. So you want to find the angle, and this phase angle is the phi. You know phi, between the current and the source voltage. So how to find that? in this diagram, we only have the Z. You see, we only have the Z. Current is with resistor. So where is the V source? Where is the V source? I told you before. V source is for Z. You see that? V source is for Z. So V source is parallel with Z. V source is together with Z. This is the V source. This is the V source. Yeah, V source is over here, so same direction with Z. V source is same direction with Z. So the question asks for angle between current and voltage. Current is with resistor. Remember, current is in phase. Current is in phase with resistor. Okay, current is in phase with resistor. V source is together with Z. Okay, so the angle between current and V source, of course, is this one. This is the phi. Remember? Very easy. Okay, good. So we want to find the phi. How? We have the R, we have the Z, isn't it? We have the R and we have the Z. So this is a right angle triangle. Adjacent over hypotenuse. Cos phi is adjacent over hypotenuse. Adjacent is R. Hypotenuse is Z. Hypotenuse is Z. Do you know that R is actually the X component of Z? Write it properly. R is the X component of Z. Okay. So this is actually like adjacent over hypotenuse. Okay. So we can find the phi lah. First of all, just substitute all the values. What is our R? Okay, so what is our R? Our R is 900, and our Z is what is my Z here? 1434.72. Okay, then you anti-cos everything, anti-cos, yeah, your blah blah blah, and what the answer for phi is 51 degree. Okay, 51 degree. You work it yourself, yeah. Try and find, is it 51 degree? Okay, that's it. Now, next, is the current leading or lagging the voltage? Obvious already. Once you have the diagram, it's easy to see. Now, is V source leading the current? Is it not? V source, because it's rotation anti-clockwise. Rotation anti-clockwise. So V source is in front of current. So we just write V source leading current, because we know XL is bigger than XC. That's why, because XL is bigger than XC. That's why V source is leading. Okay, just right there. V source leads current. V source leads current by phi radian. That's how we write it. If you have any problem, please comment there. Please comment there. If no problem, you just write no problem lah. Okay, thank you. Now, what is the power factor for this circuit? Power factor is, what is power factor? Cos phi. Power factor is cos phi. So, actually, we can find cos phi over here. Just now, we find cos phi first before we can find phi. We already can find the cos phi. Just now, we already got the cos phi already. But later we find the phi, isn't it? This one is just cos phi lah, so it's R over Z. Yeah, the cos phi itself is the power factor. So that answer, R divided by Z, you will get 0.629. Okay, 0.629. That's it. Okay, easy. Okay, now let's move on to the next question. Yeah, let's move on. Thank you for the comment. Yeah, love you all. Okay, now let's go to the question 5. Question 5. Yeah, this is the and don't bother about writing first. Later, you can I will print screen this for you. Yeah. Okay, so a capacitor is connected to a source. Seems that this is a, so identify what kind of component. Yes, only capacitor. So this is a pure capacitor. You must first know what kind of component is a pure capacitor. Now, That's it. So this is the capacitance value. Now he say this source has this kind of voltage. So this is definitely V source. Understand? This is for V source, not is for V source. But this is a pure capacitor circuit. Pure capacitor circuit. So that means is the V source is directly proportional to is directly opposite to the capacitor. So this V source, because it's only pure capacitor, that's why this V source also equal to VC. You understand that? Because only one component. Unless you have a multiple component like RCL circuit, let's say you have RCL circuit, you have source, you have so many other component, resistor, capacitor, inductor, inductor. So this one is V source, and then you have here you have VR, you have VC, you have VL. For this case, V source is not VC. Understand? It's not VC. It's not VC because it's not pure anymore. It's not pure. It has many components. Yeah, it's not VC. But for pure capacitor, the V source is equal to VC. For this one, V source equal to VC. Hope you understand, yeah? You got this, right? Okay, so V source is equal to VC. This one is not, yeah? Because it's not lah, it's not. V source, if you want to find the V source, this one you have to do all the mumbo jumbo, yeah? You have to do all the mumbo jumbo. You have to do find VR first. You have to VL, VC, everything, and then only you got V source. So you see the V source is not the same as VC. Yeah, it's not. It's not the same. Yeah, it's not the same. Okay. This one is definitely pure capacitor. Is V source is equal to VC. All right. Too much time wasting over here. Let's move on. Okay. Okay, let's move on. So we have okay, this is V source equal to VC. So I've written down here micro change to SI unit. Okay, so V source equal to VC, which is because this is a sine equation, so I just put sine omega t, and VC, V source is VC, so VC is V naught C. This is the peak value, the maximum value, V naught C, sine omega t. So I compare with the equation given. This is 240 sine 120 pi t. So from here I got it. The goal value, the keys of it. This is V naught C, and from here this is omega. Yeah. Okay, so I got V naught C is 240, omega is that value. So these are the useful values, golden key for it, for this question. Now, what is the reactance of this capacitor? So Xc is 1 over omega C. That's the usual formula. So just write in wherever values you have there. Omega is 120 pi, and C, come on, give me the C. Do I really have to write all these values? Yeah, it's just wasting time, isn't it? Yeah, but you know lah, yeah. Okay, so the answer is once I substitute all, I calculate. I don't have calculator. You calculate for yourself. It is 8842 ohm. Okay, the unit 8842 ohm. That's the unit. Okay, ohm. Ohm. Not farad. Farad is for, this is this capacitor is farad. This is ohm. Don't mix up. Yeah, don't mix up. This is farad, is capacitance. Now, let us find the next questions. We already got the reactance of capacitor. That is the XC we need just now. That's the XC we already got just now. Now, determine the root mean square current flow through the capacitor. Root mean square current. So he want the root mean square current. So how to find root mean square current? We already have the V naught C, isn't it? V naught C. So just apply the formula. V naught C is I naught XC. You only have the capacitor, isn't it? V naught C is I naught XC. So okay, just put in the values. Yeah, put in the values. So this is V naught C is 240. So my I naught, I need to find I naught XC. I already got 8842. Then you get your current I naught. I don't know what value. You calculate for yourself. Then you get I naught. You can get I RMS, isn't it? I RMS. So I naught over cert2. That's the answer for I RMS. Okay, I calculate. I got 0.019 ampere. 0.019 ampere. That's it. Very easy. Okay. Understand? Okay, let's move on to the next question. Yeah. Thank you for your comments. Yeah, it keeps me going. The motivations to continue. Yeah, all comes from you. Thank you so much. Yeah. Okay, so now question 6. The question 6. Now question 6. Yeah, this is the questions. Yeah. Okay. So now a circuit consists of capacitor. So first, what is the first step? What is the first step? Yeah, look at me. Look at me. Look at my face. Yeah. What is the first step? The first step is to identify what component is it. Yeah. Identify what component is it. Okay. Now let's move on to our questions. Yeah. Okay. Okay. So component. What component we have here? We have a capacitor. We have a lamp. Oh, lamp. What is lamp? Lamp, of course, it use energy, isn't it? Use energy is, of course, resistor. Okay, capacitor. So this is a RC circuit. There's no inductor. RC circuit. Understand? RC circuit. This is very important because you must identify what kind of component first before you can draw the phasor diagram. Understand? Now, okay, RC. Okay. So what values you have? This is definitely the capacitance, not the XC. Not the XC. XC is unit ohm. Unit ohm. This is farad. This is farad. Farad is C, not XC. Not XC. XC you need to use formula to find first. Okay. Not the XC. Not XC. Okay. This is only the C. Now, you know, students sometimes very good. Okay. So now this lamp is 2.5 volt current frequency 50 hertz source. Okay. Now he said this 2.5 volt, is this the source voltage? Is this a source voltage or the lamp voltage? What do you think? This 2.5 volt is written just next to the lamp. Of course, it is a voltage across the lamp, not the V source. Okay, because it's written just just across the lamp. So this is the V. Okay, he didn't mention this is a peak voltage or root mean square voltage, isn't it? No mention at all. I did tell you, if no mention, it is root mean square value. It is root mean square value, and it is written just beside the lamp. Of course, it is voltage across the lamp only, not the source. Not the source. Okay, so and this current is current across what? Is it current across only the resistor? Only the resistor? Is it the current only the resistor? And capacitor have different current? Is it have different current? Come on, man. Come on. This is a series circuit. Series circuit, of course, they have the same current. We don't have IR and we have XC, IL. We IR, IE, IC, IL. No, series circuit. They all have the same current. They all have the same current, which is the same as the total current, the same as total current. So we don't write as I current across resistor. No, they have the same current. So just write this as, and this one doesn't mention is peak current or root mean square current. No mention. No mention means root mean square lah. No mention means root mean square current, and we same current for all component. Okay, same current for all component. No mention means root mean square value. Yeah, unless it mentioned this is a maximum current or peak current. You know, peak, not the peak you think. Is the peak, is this peak? Peak. The maximum current. But this is not max. No mention means root mean square value. Okay. Too much of talking. Now this is the frequency. Okay. Now, what else? So I write down all the information here. Yeah, this is the C. Okay. Root mean square. Root mean square R not specified means root mean square value, current, root mean square current, frequency. So I write down all the information here. Now I want to find reactance of capacitor. I have half an hour more. Yeah, I can finish this. Yeah, reactance of capacitor and resistance of the lamp. How to find reactance of capacitor? Just use formula. Reactance XC, 1 over omega C. That's a formula. Do I have all the values? Yes, I have frequency. I have C. So just calculate. That's all. Yeah, 1 over 2 pi FC. That's it. Yeah, 1 over, yeah, all right, good. 1 over 2 pi FC. So you just substitute all the values, frequency, the capacitance, and what's the value of XC? 3.18 ohm. You see, I just use my mind and I calculate. I got the answer already. So good is it? Wow. If I have the type of brain, I will be very grateful. Yeah. Okay. So that's the XC and resistance. Resistance of the lamp is given, not given at all. We only have VRMSR. Why VRMSR? I have the IRMS. What you waiting for? Just use VRMSR equal to IRMS resistance. That's it. So 2.5 equal to 0.3 resistor. So resistor equal to, I use my brain, I calculate, oh, it is 8.33 ohm. Yeah, what a good brain I have. Yeah. Okay, so that's the answer. Yeah, 8.33 ohm. All right. Okay. That's good. Now, I already have XC, X, and R. The next question should ask me about impedance. Is it? Yeah, B asked me about impedance. Expected, yeah? So impedance is Z lah. You want to ask us about the Z. I need to find Z. What do I do? The same process again. This is the RC circuit. Draw like RC phasor diagram. Okay. Remember, draw the axis first, X and Y axis. The current always at the x-axis, R in phase with current. XC is always below, yeah, always below. This is it. And R and XC together, we have the Z. Z is the Pythagoras theorem. So can you find the Z? Yeah, just use Pythagoras theorem. I already have the XC and R. What are you waiting for? Okay. So Z is, you know, Z is, let me figure out, R square, XC square, Pythagoras theorem only. And then you just substitute all the values here and you get Z. I calculate in my heart and I got this answer, 8.92 ohm. Okay, 8.92 ohm. That's it. Okay, very simple. Okay, later you work on your own, yeah? Don't just copy, yeah? You need to do some effort also, yeah? You need to do by yourself, okay? Now, good. Now, how about the voltage across the source? Source voltage. Didn't mention, is it the peak voltage he wants or is it the root mean square voltage? What do you think? It didn't mention. Now I ask you, yeah, voltage of the source. Want the peak voltage or source root mean square voltage? Of course, it's root mean square lah. No mention ma. Okay, root mean square source. And then the next question, voltage of capacitor. What did it ask for? No mention. Of course, root mean square lah. Okay, so very hard to find. I already have the, you want to find root mean square source. I have the Z. Z is corresponding to the source, isn't it? Okay. And then wait. For capacitor also the same. Voltage of capacitor also the same. Voltage VRMSC is XC lah. Okay. So root mean square ma. You want the root mean square value ma, isn't it? You want the root mean square value. So the current also put the root mean square current lah. Okay, put the root mean square current. I already have the root mean square current what? So just put in the value lah. Okay. So root mean square current. Root mean square current is 0.3 Z. What is Z? Z. I calculated just now is this one. Just put in value. VRMS source. I got it. I calculate in my heart 2.680 2.68 volt. Wow, I got the answer. Fantastic. Okay. Now, how about the next one? VRMSC. Just put in the root mean square current lah. Yeah, put in the root mean square current. XC. What is XC? I got the XC just now. 3.18. Yeah. It's just like you eating groundnuts. Okay. The answer is 0.95 volt. Okay, that's it. Very simple. Okay, now. Okay. Explain why. Wait. Who is haha lol there? Who haha lol? I don't. Okay. Wait. Explain why the total between the voltage across capacitor and the lamp is not the same as the source voltage in C. Do you understand? Yeah, you not understand because I read too fast. Yeah, now I read slower. Explain why the total between the voltage across capacitor, okay, the voltage across capacitor, put this as the root mean square value lah. No mention means root mean square value. And the lamp is the resistor. The resistor VRMSR. No mention means root mean square value. Is not the same. Not the same means not the same. As the source voltage. Source voltage means VRMS source. Itu maksud dia. Kenapa? Why Malay? Sorry. The total means plus together. Plus together. Why the total of root mean square capacitor and the root mean square resistor? Why the total of them not the same as the source voltage? Why not the same? Why? So this is the question. Why the root mean square source is not the same as root mean square capacitor and resistor? Why not the same? Of course. This is only for DC circuit, you can do like that. Understand? For DC you can total up. For DC series, you just total up. Because DC series we just V1 plus V2. Understand or not? But this is not DC. This is AC. AC, you have to use this. You have to use a phasor diagram. You cannot just total up. Understand or not? Because why? Because they are not in phase. The value are not in phase. At this time, value at certain time resistor voltage is maximum, but at that time voltage of capacitor is 0. So they have different voltage at different time. So you cannot just total them up. That's for DC only. For AC, you have to do phasor diagram. That means you have to you have to, you have to I don't want to waste too much time here. That means it's just like VR here lah, and then XC is VC. Then you have to then only you can get the V source. Understand or not? This one I put resistor, but if voltage I just put voltage, VR and VC and V source. Want to find V source? If you want to find V source, is use Pythagoras theorem also. It's Pythagoras theorem also. That means the VRMS R square plus VRMS C square. That's the way. Pythagoras theorem. You cannot just total them up. Understand? So what's the explanation? He asks you to explain. Explain. You can put this value also lah. You can draw the phasor diagram for the examiner, and also you give this this should be the way instead. This one is correct one. This one is correct one. This is the wrong one. Not for AC. Okay. This is the way to find the root mean square source voltage. And the reason you can add in some words. You can say what? You can say because the VR and VC not in phase. They are not in phase. That's it. They are not in phase, so you cannot just total them up. Understand? Okay, that's it. Now let's move on to the next question. Next question. We have 4 more questions. How much time left? 5 minutes for each question. Okay lah. Yeah. Now, okay. Let's look at these questions. Yeah. The next question are very short question. Yeah, short question. So don't be Don't bother. Yeah. Now, question 7. I have alternating voltage or frequency. Okay. Okay. First of all, look at me. No need lah. So, what kind of component you have here? What kind of component you have? Only you have resistor and capacitor. You have resistor and capacitor. So this is the RC circuit. RC circuit. So this is the resistor. This is the capacitor. This is the. Is this a C or XC? Is this a C or XC? Farad. Farad. How many times I need to repeat? Farad. Farad is C, understand? This is C, not XC. XC, you have to find some more. Okay. So I have written down all the information here. Okay, frequency RC. So you can find the XC. Okay, the formula 1 over omega C. Okay. I substitute all the formula. Yeah, the same process again. And if I substitute the value, it's wasting time. I better just write down the value 530.52. Okay, 530.52 ohm. That's it. That's the answer. That's the reactance. I'm getting tired. Yeah. Okay. Now, what's the total impedance? What's the total impedance? That means this asks for Z. Ask for Z. Ask for Z. So, okay. Again, you have to draw the phasor diagram. This is the RC circuit. So just draw like RC. So current first, then resistor with current XC behind the current. Yeah, rotation anti-clockwise, isn't it? So XC is behind current. So this is a Z. So you do again the Pythagoras theorem, and you know lah, XC square and R square. And the answer you get is 609.47. That's it, 609.47 ohm. That's it, ohm also, huh? Okay. Now, with the help of the phasor diagram, determine the theta between the current and the voltage applied. Again, the same question. So this asks for the current and the voltage applied. This is considered the V source. Understand? Voltage applied V source. So what's the angle between them? Between the current and the V source. Current and V source. So just look at the phasor diagram. Current, where's the current? Current is always with the resistor, and V source is with the Z. V source is at the Z. So V source is over here. So understand? So this is the theta. We normally say this as phi, but sometimes the question one use theta. What can we do? We just follow theta lah. It's the same as phi, yeah. So now it just changed flavor to use theta. Yeah, just use theta lah. Okay, so to find the theta, just use cos phi. Actually, this is the power factor. Yeah, just again, it's the adjacent over hypotenuse. Yeah, the same thing over again. So R is what is the R? Come on, give me the R. 300. 300 over Z. 300 over Z, which is 609.47. So anti-cos, and the value is, oh, no answer. No answer. So you check the answer scheme lah. Yeah, you check the answer scheme. You give me the answer, theta. Yeah. Okay, my brain is tired. I cannot calculate anymore. Okay, so now okay, so number 8. Let's look at number. Wait. One thing I want to tell you. In objective questions. Objective question can be tricky. The current not always at the x-axis. You understand? Not always at the x-axis. If you have an RC circuit like this, that means it is current leads V source already by the phi radian. Yeah, by the phi radian. So currently, so not necessarily the current must be at the x-axis. It can be some secrets I tell you, because I have reason for it. Okay, so it can be current over here. It can be wait. It can be current over here. It can be V source over here. Understand? V source. As long as current leads voltage by phi. It can be also as long as not 90 degree. If RC circuit confirm you have resistor, isn't it? You have resistor, the phi cannot be 90 degree anymore. The phi can never be 90 degree. It must be smaller than 90 degree. Because why? Because got resistor. You understand? Because got resistor. It can be like this also. It can be maybe it can be maybe it can be maybe it can be maybe it can be like this. Current over here. V source is over here. Anywhere, actually anywhere. As long as the current is leading the voltage. Understand? Current is leading voltage. As long as for rotation anti-clockwise. You understand? Always only anti-clockwise. There's no clockwise. I never teach you about clockwise. I only teach you about anti-clockwise. So as long as rotation anti-clockwise, the current is leading in front. That's it. That's correct already. So all this diagram is correct. All this diagram is correct. It can be like this, can be like this, can be like this. This is only for one example. There are many other examples like this, like this. Okay, I don't know. But in objective question can be like that. So don't thank me after that. Yeah, thank me later. So what if, one more question for you to ponder? What if RL circuit? What if RL circuit? What do you think? RL circuit. What do you think RL circuit? RL circuit. RL circuit. Can I finish all the questions? I wonder. So RL circuit, I know that you know, traditionally I always draw current here, isn't it? Current over here, and then resistor is here, and then I like green color more. I get R. X. What do you think is XL? What do you think? XL is always in front. Yeah. Because why? You know, this XL is the same as VL lah. It's the same as VL. Just now, like I also thought, resistor is just like the voltage lah. I can say resistor is just like the voltage, just like the impedance is like the V source. Yeah? Voltage and resistor together. Understand? Voltage and resistor together. That's all. Yeah. So this is like VL. We know that for inductor, voltage lead current, isn't it? Voltage lead current. So that's why XL at the top. XL at the top because voltage lead current. You know Ellie. You know, remember Ellie? You know the one who named Ellie. Is a very popular person, isn't it? Okay. Okay. Enough for that. Now, see, this one is, so we have the Z over here, isn't it? Z. So Z over here, that means, this is the Z lah. So Z, V source is together with Z, understand? V source together with Z. So that means the phi here. So we can say for RL is V source leads current by phi. V source lead current by phi. So it can be the we don't make our head only think one way. No, our head is multi-purpose, multitasking. Don't just think one way only. It can be you know, it can be you can put a V source over here. It can be put a V source over here, the current over here. Understand? There are some variation on. As long as the V source is leading, anti-clockwise, understand? As long as V source is leading anti-clockwise. So there are many other diagrams. I don't draw over here. If I draw over here, no need to explain other question already. Okay. So try to think of it. Yeah. Okay. So there are many other variation of it. Yeah. Okay. This I only taught one variation only now. Okay, now come on, let's move on to the next question. I haven't taught you about the power and the resonance yet. Yeah, maybe for the next lesson now. Okay, now, okay. Let's look at these questions. Yeah, okay. What kind of circuit we have here? We have the inductor. We have the resistor. This one is Henry. Who doesn't know Henry? Everybody knows Henry, isn't it? Henry is for L lah, yeah, for L. Henry is L, not XL. XL, come on, XL is for ohm. Understand? It's a resistance. Not XL. XL you need to find. Okay. So L, this is L. This is a resistance. There's a resistance. Okay. This is RL circuit. RL circuit. Good RL circuit. And this root mean square voltage of 230. This one just put beside the source, isn't it? Of course, this is source voltage lah. So this one is root mean square source voltage. That's why I put VRMS source is 230 volt. Okay, frequency this one. Okay, I have everything here. Now calculate the reactance of inductor. Reactance of inductor is omega L. Omega L. Be careful with the all the formulas. If XC is omega is below, you see. Omega is below. XL omega is proportional. Proportional. So be careful with the. Wait. This is omega C. Omega C. How can I make such mistake? Okay. So be careful. No, now XL. XL. Find me the XL. Come on. Put. I wasting time writing this. I'm wasting time already. I'm wasting time. I calculate 219.9 ohm. That's it. Okay. That's the answer. Impedance. Come on. I just draw this lah. XL. No need explanation, isn't it? So Pythagoras theorem, and you got the answer 266 ohm. Okay, come on. Let's move on to the next questions. Question 9. Oh, this is about power already. Power. Let's skip this question first. Okay. Question 10 first. Question 10. Let's question 10 first. Now you have this. VAC source of 10 volt root mean square. This is VRMS source lah, 10 volt, isn't it? And frequency and consists of inductor. Okay, what circuit? What component is it? What component? This is inductor and resistor. So this is I have where is Henry? Who is Henry? Henry is the one who named L. Okay, so this is the resistor ohm. Okay, so RL circuit. This is RL circuit. So now you ask to find current flows. If you want to find current, and first of all, you must find impedance. That's the first step. This is the person you need to find first. Who is this? You as detective. Let's find out who is this. Zach. Okay. Okay. I want to find the current. So I have the V source, I have everything. So I don't have XL yet, isn't it? Find XL lah. Find XL, omega L. Okay, omega is 2 pi F L. Okay, I got the answer. I got what is the, I don't know. What is the value? I don't know. Yeah, because it's not given. Yeah, you need to calculate lah. Just use the formula to calculate. Okay, now find the impedance. Who is Z first? You want to find Z. You need to find Z first before you can find current. Understand? If you want to find current, you must find Z first. Okay, this is the RL circuit. You need to draw like this. Current, R with current. XL is like VL. XL is like VL. Voltage lead current. For inductor, voltage leads current by 90 degree. So XL is here. Okay, so this is Z. Okay, let's find out the Z. I got the Z already. Pythagoras theorem. I have the. Oh my God, here don't have any. I don't have a calculator. Basically, I just want to tell you, my brain is not that good. Can calculate everything, so I don't have the Z over here. You calculate for yourself. Okay, please. Okay, you got your Z already. Now it's time for you to find your current because I have the root mean square source. I have the source voltage. I have the total impedance already. The impedance is corresponding to the source. So I can find the current. I can find the current. He specified, is this peak current or root mean square current? Did he specify? Did he say this is a peak current or root mean square current? No specify means root mean square current. Understand? So root mean square current lah. I have the root mean square voltage just now, isn't it? Root mean square V source Z. I can find the IRMS. So I don't have the value all here. So you just substitute all the value VRMS source. Just put inside value. I get the current as Now suddenly my brain can calculate everything. So I got the answer, 8.47 exponent negative 3 ampere. That's the current. Exponent negative 3 ampere. Okay, come on. Just left a few minutes. Sorry for your time. Okay, thank you for your patience. Okay, so now what is the voltage across resistor and inductor? Again, no specify means root mean square. Root mean square voltage. He want the root mean square voltage for R. He want the root mean square voltage for L. Yeah, easy lah. Yeah, because I already have the root mean square current. What? So I can find everything already. I also have R. I also have XL, isn't it? I have R, I have XL, so I can find VRMS R and VRMS L. Just use the formula RMS R, IRMS XL. I can got the answer, and that's the answer. Okay. I don't want to waste time already writing all that. Now, the phase angle between the EMF and the current, you see the same question repeat itself again and again and again and again and again. So this is a V source and the current, yeah? So you want the phase angle phi lah, okay? So that means how to find? Draw the phasor diagram first lah, okay? This is a RL circuit, isn't it? RL circuit. Okay. Where is my not this one, this one, yeah, this one. Phase angle between them. So this is again, so V source is with Z, isn't it? V source is with Z. V source is with Z. This is the current over here. So V source over here. So this is a phase angle phi. So the phi, just use this equation lah. R over Z, R over Z, and then you get the phi. Understand? Get your phi. Very easy. Okay. That's it. Now, the last questions, and before we go off, draw the graph and explain graphically the dependence of R, XC, XL, and Z. No. The B, question B. What should you do that the voltage of the circuit is in phase with the current of the circuit? Okay, this one in phase, we'll talk about resonance. So I don't think I have time to explain about resonance, but actually very simple, and average power. I will leave this question for the next lesson. All right. Thank you everyone for watching. I thank you so much. Please subscribe, love, and share all these videos. Thank you very much. See you again next time. Bye.